In question 22, we're required to find the area of triangle IKH. That square bracket notation is sometimes used to denote the area of a triangle designated by its vertices. The diagram on the left is what we're given, and it contains the names of the points and the areas of the small triangles. In order to understand the area of IKH, I'm going to look at a ratio of lengths. I'm going to be interested in the ratio HI is to IF. That's a ratio of lengths, and we've got data about areas. But fortunately, everybody knows that the area of a triangle is half the base times the height. There is some controversy, however, because nobody's very sure which is the base and which is the height. However, we're at liberty to choose that. So I'm going to look at the right-hand diagram, a sort of simplified version of the original diagram. The top triangle, GIF, its area is going to be the sum of these areas, that's going to be 24, and this area down here is still going to be 8. I'm going to drop a perpendicular from the point G to the line FH. So I'm going to regard the line FH as being where the bases live. If I look at triangle IGH, its area is going to be half times its base, IH or HI, times its height, which is that red line. Similarly, the area of the triangle FGI, 24, has got to be a half times its base, which is FI or IF, times its height, which is the same. Now, if you look at the ratio of those two areas, the halves cancel and the length of the red line cancels, and all you're left with is the ratio of the bases. So we compare the ratios of those two triangles, we get this ratio here, and it's in the ratio 8 is to 24, which is the same as the ratio 1 is to 3. And now we're in a position to get at the area of triangle IKH. And what we're going to do is to compare the ratio, well, the area of triangle IKH, and compare that with the area of triangle IFK. And that we happen to know is 12 because you can read it off the original data. And again, we're going to use this idea that the bases of triangles are along this line, and the heights are going to be perpendiculars dropped from K. And if you take the triangle IKH or the triangle IFK, then they have the same perpendicular height there. So the ratio of their areas will be a half times the base of this times the height of that triangle is 2, a half times the base of this triangle times its height. And again, the heights are the same, the halves are the same. So the ratio of the areas is simply the ratio of the length of the bases. But we know what those are. This base to this base is in the ratio 1 is to 3. So that area is to that area as 1 is to 3, and so it must be of area 4. And that's the answer.